Right, so we're looking at the example that we looked at today in the class. Given that A is equal to that, B is equal to that, and C is equal to that. And A, B is equal to half C. Calculate the values of X, Y, P, and Q. Right. So AB means A multiplied by B. So that's the first thing you have to do. Whatever working out you have to do on each side of the equal sign, you have to do that and then equate your two answers. So we're going to do A, B. So we check out our equation. A, B. And of course, when we multiply matrices, we multiply row by column. So row, we separate the row in the first matrix and we separate the columns in the second matrix. And then we multiply corresponding elements, first to first, second to second. And once you have more than one element in the row and column, you have to multiply all of those. You have to add all of those. All right, so let's do that. So it's going to be negative 1 times 2 plus x times 1. And so that's the first row. Then, so that's the first row, the first column. We can move to the second column using the first row again. So again, it's going to be negative 1 times negative 1. And you can put it in bracket if you want, plus x times 3. And then we move to the next row. So now it's going to be y times 2 plus 2 times 1. And the next column, y times negative 1 plus 2 times 3. Simplifying that, we get negative 2 plus x, 2y plus 2, 1 plus 3x, negative y plus 6. So that is AB. Then now we need to work out the other side of the equal sign, which is half c. So half c is equal to half c is equal to half of c. That means half of everything that's in the matrix C. So I'm just going to do the half, right? Half of 2p, that would leave 1p. Half of 20, that would be 10. Half of 12, that would be 6. And half of 2p would be 1p. So we have worked out AB and half C. Now the question says that AB is equal to half C. So now that we've found AB and half C, we have to equate those two matrices. And we know that if two matrices are equal, then corresponding elements are equal. So now we are going to have negative 2 plus x, 2y plus 2, 1 plus 3x, negative y plus 6 equal p 10, 6, q. And we're going to equate corresponding elements. So first in the first matrix is equal to first in the second matrix because they said that these two matrices are equal. So we're going to have negative 2 plus x equals p. Two y plus 2 equals 6. And I'm lining up everything, by the way. And 1 plus 3x equals 10, and the negative y plus 6 equals q. So there are two that we can get first based on the information that we have. You look for the equation that only has one unknown. Those equations can be solved easily. If it has more than one unknown in it, meaning more than one variable, then obviously you would not be able to solve those first. We're going to solve the one with y here and x. So let me part the book page again. So we have 2y plus 2 equals 6. So we want to make y the subject. That means we need to move the constant first. We can choose double method, or you subtract 2 from both sides, or we can say that, okay, if we move positive 2 from one side of the equal sign to the next side, then it becomes negative 2. So we're going to have 2y equals 6 minus 2. So that means 2y is equal to 4. And then we divide both sides by 2 to get y. 2 cancel 2 there, so y is equal to 2. So we have y. And then now we want x. We're going to use 1 plus 3x equals 10. Transpose the constant first. So we're going to have 3x equals 10 minus 1, which is 9. And we want x, so we divide both sides by whatever number is attached to x, which is 3. And 9 divided by 3 is 3. So now we have x and we have y. So now we can look at the other two equations to get p and q. Separate my page again. So we can say using x equals 3, 1, no, that's not 1. Using x equals 3, negative 2 plus 3 equals p. And we simplify that, that would be 1. P is 1. And then we say using y equals 2, negative 2, because the equation is negative y plus 6. So negative 2 plus 6 equals q. Negative 2 plus 6 is 4. Therefore, q is equal to 4. So that's the last example that was done in the video in the class today based on our example equal matrix. Alright, so I hope you get it. Alright, so let me zoom out a little bit. Hope it's not too small. So that is the actual working out for the whole problem. Yeah. So you can, in the end, you can say therefore x equals 3, y equals 2, p equals 1, and q equals 4. And you have completed the question. All right, goodbye.